Introduction to hail formation. Hail is a type of precipitation that forms under specific atmospheric conditions and can cause significant damage to property and agriculture. Unlike regular rain, hailstones are solid balls or lumps of ice that vary in size. Understanding the formation of hail involves exploring the conditions necessary for its development and the processes that contribute to its growth. The formation process. Hail forms within strong thunderstorms, particularly those with intense updrafts and abundant supercooled water droplets. These droplets are liquid water that remains in a liquid state despite being below freezing temperatures. The formation process begins when these supercooled droplets are carried upward by powerful updrafts in a thunderstorm. Growth in the thunderstorm. As the supercooled droplets are lifted higher into the storm, they encounter even colder temperatures and begin to freeze. The initial ice pellet that forms is known as the hail nucleus. The updrafts in the storm can carry these ice pellets through regions of the storm where more supercooled water droplets are present. As the pellets collide with these droplets, they accumulate additional layers of ice, causing the hailstones to grow larger. Layering and structure. The growth of hailstones involves the repeated cycling through the storm's updrafts and downdrafts. Each time a hailstone is carried upward, it collects additional layers of ice from supercooled droplets. The ice layers build up in concentric rings, giving hailstones a characteristic layered appearance. The size of the hailstone depends on the strength of the storm's updrafts and the amount of supercooled water available. Factors influencing hail size. Several factors influence the size of hailstones. The strength of the storm's updrafts is crucial. Stronger updrafts can sustain hailstones longer, allowing them to grow larger before falling to the ground. Additionally, the amount of supercooled water in the storm and the duration of the storm also affect the size of the hailstones. Larger hailstones typically form in more severe thunderstorms with intense updrafts and abundant moisture. Hailstone descent. Once the hailstones become too heavy for the storm's updrafts to support, they fall to the ground. The size and density of the hailstones influence how fast they fall and their potential impact upon reaching the surface. Larger hailstones can cause more damage to structures, vehicles, and crops compared to smaller ones. Hail versus sleet. It's important to distinguish hail from sleet, another form of frozen precipitation. Sleet forms when raindrops freeze into small ice pellets as they fall through a layer of cold air near the Earth's surface. Unlike hail, which forms within thunderstorms, sleet typically occurs during winter weather events and involves different atmospheric conditions. Impact and damage. Hail can cause significant damage to property, including dents in vehicles, broken windows, and damaged roofs. Agricultural crops can also be severely affected, leading to economic losses for farmers. The intensity of hail damage often depends on the size and velocity of the hailstones as well as the duration of the hailstorm. Forecasting and safety measures. Meteorologists use weather radar and satellite data to detect conditions conducive to hail formation. Forecasting tools can help predict the likelihood of hail and provide warnings to minimize damage. Individuals can protect themselves and their property by seeking shelter during severe thunderstorms and taking preventive measures to safeguard vehicles and structures. Conclusion. Hail forms through a complex process involving strong thunderstorms, supercooled water droplets, and powerful updrafts. The growth of hailstones occurs as these droplets freeze and accumulate layers of ice. Understanding the conditions that lead to hail formation helps in forecasting and mitigating its potential impacts. Proper preparedness and awareness can reduce the damage caused by hail and enhance safety during severe weather events.